Okay, this is going to be a big video. This is very nerdy, and this is for people who care about HVAC design calculations and how exactly they're done, which we're doing a series on this channel. So if you're not subscribed already and you find this level of nerdiness appealing, then please do subscribe. But what I want to show today is why I make the attic conditioned space, not just encapsulated, which is a word that I'm putting quotes around, and I will explain that's part of the why when I do HVAC designs, and then also how exactly I do it. And the why and the how are going to interweave, because we're going to go through a bunch of different iterations of the dominoes that start falling when you see what impact this has. So we're looking at this house right here. We can see a floor plan in front of us. This is a very big house. It was built by a client of mine who lives in it. He is a builder, and he wanted to show off what he can do to his clients, and so this is fancy. Very sprawling layout, and also very high ceilings. So this floor has 12-foot ceilings. This second floor, this has 10-foot ceilings, so we got this storage area. You can see also this dotted line. That is the footprint of the first floor underneath. And so we've got, in the case of many of you who are thinking of doing an encapsulated attic, we have an attic above this, and if I'm going to do the design the way that 99.9% of all HVAC pros are going to do it, and I will show you why they do it that way in a moment, then I would just not be counting these rooms that are above. The encapsulated attics are not a part of my equation. However, the first thing that you'll notice when we zoom out here is that this is what the house looks like from the elevation standpoint. So from the side, you can see there's a huge amount of encapsulated attic. This is not like a light encapsulated attic. We've got massive 12-12 pitch. I have clients who do 14-12. I've seen 20-12. Architects are doing all kinds of fun stuff with attics these days. So if you're going to encapsulate this space, what I like to always do is build them into the actual 3D model. Here's your first example of why HVAC professionals do not do what I am describing. I'm going to build this entire room here, which is, as you can see, sitting on top of the two floors. So again, if I was going to do an typical HVAC design on this, I would just do those two big blocks. What I'm going to show you today is called a block load. We're not worrying about specific rooms in this plan. But we can then build this room on top of it in 3D. If I was trying to do this on a piece of paper, no way. Like, this is just not going to happen. And in fact, this kind of a thing takes me hours to build. And I find it worth it, and I will show you why in this video. So I hope you hang in there with me. Really what we have here is 3 independent rooms. These zones are all mystery rooms inside the space that I am going to show you how to build them in as independent rooms that need BTUs and CFM within the home. So let me explain first, broad strokes, why I like this approach. I come from enclosure testing. So my background is as a blower door tester. That was my first thing that I did, a blower door and an infrared camera, and I was going in Chicago. And what I found was that most of the problems that we have in homes are because of rooms being either kind of confused about what they are. They're not sure whether they're inside or outside, or they look like they're one thing, but they're actually acting like they're something else. And the only way to know either of those things is through testing, which I highly recommend. If you have not had a blower door test done, you got to do that. It's as old as I am. I'm 46 years old. The blower door was invented the year I was born. Most people have never heard of it or seen one. That's a shame. So we're trying to change that. So if we can just make it black or white, every zone in the house is either inside the house or outside the house. And quickly, there's 3 kinds of zones that you'll notice in homes. There's interior space, which is clearly inside, furniture and carpets and things like that. There's clearly outside space, grass and trees and things like that. And then there's these confusing spaces, which this giant room on top of the house counts as. It's kind of like inside, meaning we kind of want it to not have all the rain and the animals and stuff in it. But it also doesn't look like it's inside. We're not going to live up there. I'm not going to put furniture up there. I wouldn't want to like have my mother-in-law sleep in my attic or in my garage or in my vented crawl space. So it's kind of confusing, and I'm going to make this not confusing for you at all. Buffer space, which is what we call these spaces, should be exactly like outside in every way except for no precipitation, no animals, no wind. So they should be the same temperature and humidity as outside. That goes for garages, vented crawl spaces, vented attics, and little like mud rooms and weird things that are kind of, you'll know when you see them. So this space, since it's encapsulated, and I'm putting what I think of as, in this kind of case, we're definitely using spray foam. If you've not seen spray foam addressed on this channel, please do go and check it out because we've got lots of things to say about it. But it's a tool, you should use it, and this is a perfect example of a house where we're using spray foam in the attic. Spray foam's marketing, at least, is that it is going to give you an airtight and well-insulated layer. If you're going to put that insulated layer at the roof line, then you are saying to the universe, this is a room in my house. This attic belongs to me, and I am now in charge of it. We are not adding insulation at the floor of this. So let's first go over into Wrightsoft and look at this layout here. So this is Wrightsoft. It's one of the several main softwares that we're using to build manual J calculations, followed by a manual S, which is the selection of the equipment based on the J, and then the duct design, the manual D, happens on the back of the manual S, which is the selecting the equipment. Okay, so we can see that I've got like one piece of equipment in here on this floor one block. You can see the layout. I have double checked that my length here is scaled proportionally for my plan. It's 126 feet long end to end with those 12-foot ceilings. And so we can see floor one, we can see floor two, we can see that I have not modeled in these rooms. And what we can see over here on the load is that our total heating load calculated is 105,000 BTUs per hour at max. That's the 99% coldest day. By the way, we are in Topeka, Kansas here, right in the dead middle of the US. So I'm going to put the house there in all the different models that we're running. When we come back here, we can see that I have, in this case, a ceiling that is ceiling under attic. And this, I'm imagining you guys are blowing this up to full screen so that we can see this together, but like, you know, there's going to be little details that I'm putting out. I'm going to read everything that I'm talking about here. So we've got asphalt shingles, dark in color, with an R25 in the roof deck. So between the roof rafters, there's R25 spray foam. We have it encapsulated. The attic is an encapsulated type, and that changes the nature of how this software is going to treat it. There's no ceiling insulation on the backside of the ceiling drywall. We have half-inch drywall there separating the living space below from this attic. That's it. Okay, so then we've got all these U-value nominal CLTD group, which is the temperature of, that's rather the how much heat, radiant heat from the sun, certain materials are going to absorb. That's the CLTD group. Then you can see that we've got manual J U values assigned as well, which is very close to that. Okay, so we have one other thing that I'm just going to point out here. We have a garage that's unconditioned, and that goes into the partition value. So here, if I click on floor one, I can see in walls, I have 3 wall types, and I'm going to get into all 3 of these in this video. This is a very Wrightsoft specific video, by the way, and I'm just going to warn you, I have used Elite Soft, which is for our HVAC, and I have also used Quick Model. And Quick Model I'm going to make a note about because it's got an interesting feature that neither of those other 2, I believe, has. Okay, so wall 1 is an exterior wall type. You can see that we've got the walls here modeled as brick exterior, half-inch sheathing, with an R21 in 16-inch on-center 2x6 framing with half-inch drywall on the inside. No exterior continuous or anything like that. The second wall type here is for partition walls. That's walls between interior space and buffer spaces, which I was just mentioning. And we can see that that is built exactly the same way. It just happens that when I press OK, it's going to say, ooh, partition adjacent conditions. Why don't you tell me if you want something specific, and I can use what's called F8, which is you press F8, and I can change this value. Right now, it's assuming that in wintertime, I'm going to have a 9-degree temperature difference between inside, or excuse me, there's going to be a 9-degree temperature in the garage, which if I'm inside at 70, that's a 61 degree temperature difference. In cooling season, I'm imagining that the temperature is going to be 88. And when I go back into, when I go back here, I can see that 9 degrees is my outdoor temperature. So it's assuming that the garage is going to be exactly the same temperature as outside. And then I can see that in the summertime, the garage is going to be about 7 degrees cooler in the model. In my, I'm just going to say this, but most people these days, if you're building new, you're going to have garage doors that are not like super leaky and super uninsulated. Most people are going to be like, well, I don't want my garage to be 9 degrees. That's going to be frozen. I'm going to have frost on my car. I'd rather it be like 30 degrees. So why don't we insulate the garage? So at that point, I can come back in here and change that value. So when I press OK, it's going to ask me, hey, adjacent space temperatures may be overridden to handle special situations. I think this is a special situation. My client is doing better things to it. So let's say it's 32 degrees. They're going to keep it from freezing in there. Or if you want to be more conservative, you could say, hey, it's going to be 5 degrees warmer in the garage at all times, in which case I can make this 14 degrees. They've already lowered the summertime temperature in there. So anyway, that's not going to have a big impact on our load over here. You can see that we haven't changed very much in either case here. Okay, now the first thing that I would like to point out as we follow into the depths of the details that we're going to get into here is that we've got a 105 heating load and about 30, we could say 31,000 BTUs, so that's a little bigger than a 2.5 ton cooling load. A ton is 12,000 BTUs, so 30 would be 2.5. We're at about 31. Okay, now when I go into, let's just do floor 2 because it's obvious that we're going to need this. In ceiling, nowhere in here does it say what's the roof pitch. And you can obviously think, if this was a 312 roof pitch, we'd have a lot less roof area. Now I can tell from the footprint of my roof here that this software is thinking that I have 7,572 square feet of attic space. And when I in fact go in here to my floor 2, which is just this portion right here, it thinks I've got 3739. And let's just double check that real quick. In the ceiling, I have 3636. That's rounding errors between softwares. So don't worry about that. Part of what we're doing between the 3D model and this is truing up and making sure that we've got the same size for both of these. So around 3,600, 3,700 square feet of roof surface area. But really what we've got here is instead of the total of 7,500-ish, you can see that we've got 10,961. So we have an extra almost 50% floor of surface area. And since that's not an input in Wrightsoft, it makes me a little nervous. Like, how are they calculating this? I will say that in Quick Model, which is a 3D Manual J software that is built by my buddy Russ King, who's been on this channel, and he's going to be on the channel again soon because they've got a new thing that he wants to show off. There is an input for the roof pitch, and so they're able, I think I would trust the Quick Model's output on an encapsulated attic a little more than this. But just because there's no inputs here, it's going to be somewhere between, 10% more and 50% more surface area. And the surface area is the whole thing. Just to clarify, in this kind of a situation here, we have this room, living room. Any HVAC guy is going to step in here and say, hey, this room is huge. I'm really worried about this space here. We're going to need a lot of air in this. And so I want to have multiple, registers, and I want to have a lot of air delivered in here. However, this room, being about half the size of this room, size-wise, has more exposure area. The exposure is the surface area of the walls. This wall and this wall are both going to outside, versus in this giant room, there's only this one wall. That's all that's being exposed. So technically, this room should get more CFM than this room. Okay, so the surface area is what we're worried about here, and that's why I'm making a big deal about it. So now, let's take this, and we're going to take this 10,548 CFM, or excuse me, BTUs, and in the summertime, 31,000 BTUs of cooling. Okay, so now we're going to switch over to how I do the conditioned attic, the full conditioned attic. And you can see that on floor 1, by the way, just before we flip over to the other model, we've got 1,076 CFM being delivered to floor 1. When we go over to the other file, you can see that now we've got 1104 CFM being delivered to floor 1. That's not a huge difference, but you can see that we're already making a difference. And the difference is here. So we've got floor 2, just like we had before. Instead of saying that this floor is under an attic, it's actually under this thing, which is the attic on the top. So I have 3 new rooms that I have built into this. Attic top, attic game, which is over the game room, and attic master. And each of those is now going to be assigned a CFM. Okay, now, first thing that I need to do is let's use attic master because it's the smallest one, and also we'll just start there. By the way, quickly, over here we've dropped several thousand BTUs. Now, this is not accurate, but I just want to show you that this is changing already. We have about 34,000 or 35,000 of cooling needed and 102,000 of heating. So our heat has come down, our cooling has gone up. So this is just something to look at. Now, when we go into attic, the first thing that I'm going to do is in my property sheet, I'm going to need to set the volume so that this is correct. Because one of the things that we are aiming for here in high performance homes is certain air tightness targets. And this builder is aiming for 1 ACH 50. I'm very happy to say that almost everybody that I consult for, normal people, without any training in construction, know what their ACH 50 target is. And I don't even ask them what their ACH 50 target is. I ask them, what's your air tightness target? And most people know to say, I'd like sub 1. Like, that's super cool. I have to say, there's a lot of cool people out there. Okay, so in this attic, what first thing I need to do is set the volume. Okay, so we go back into our 3D model, and I have these 3 rooms broken out. So here is my attic master zone. And you can see that it's weird shaped because it needs to fit up against the other roof like so. Okay, so it might be actually air connected, but we're going to go ahead and treat it as its own room because just like a hallway connects 2 rooms, it's okay. You can treat them separately. So the floor area is right here. So what I'm going to do is I'm going to take the volume, which over here, by the way, in case you build a 3D model like this in SketchUp, and I've got videos on SketchUp that I'm linking on screen right now on how to start using this. It's great. They have a educational license if you're just using it for teaching yourself or if you're a teacher. We got 8,066 cubic feet of air. If you find that it's not giving you a volume, get this extension. It's a plugin or an extension. It's called Solid Inspector. And it can show you what's wrong with your model. And right now, all I've got is that the colors are weird because they're reversed. Don't worry about it. But it's giving me this number, and I can basically just fix it inside of that tool. So I have 8,066 cubic feet of air. I'm going to divide that by the floor area, which is 902.5 if I want to be nerdy about it. 8.9 is our ceiling height. So in this attic master, instead of 9, I'm going to make it 8.9. Am I splitting hairs? Yes, but here's the thing that happens with almost everybody else's designs when they're being floppy about it. You build fat into every single thing that goes into the software, and all that little bit of fat adds up to a giant blob of fat at the end. And then what we do is any HVAC guy is going to add more fat at the end. He's going to say, oh, well, our load is 4.01 tons. Let's go 4.5 just to make sure. And in fact, like 25% of your load was already fat that you didn't need. Now we're just adding more. It's called job security, okay? I'm just going to say that. So, you know, there is an incentive for HVAC pros to do this in a floppy way. And there are guys out there who don't do it that way, and they're on my list. So I'm linking the list on screen right now. And if you're an HVAC pro who cares about science and you do these kinds of things that I'm talking about, nerding out this hard, you should be on that list. And this is for a list for installers, by the way, not designers. So if you're a fellow designer, hello, but don't join that list. I'll have another list soon. Okay, so now we've got the volume in here correct. This is adding the right amount of volume. Now what we need to do is go into the surface area, because this attic is modeled right now to have 843 square feet of ceiling area. What it actually has is 1383. Okay, so we take 1383.15, don't worry about, I'm not gonna bore you with decimal places, minus 843, and I've got a difference of 540. Now we come to the third wall type. The third wall type is here, and I'm going to add that 540 square feet to it. So now I have wall 3 being 540 extra feet that was not accounted for in my ceiling. Wall 3 is very interesting because it is assignable. It can be whatever you want it to be. So this is a very specific Wrightsoft thing. How I want to build this library item, this component of wall 3, what is it? First I have to go into ceiling. I'm going to go into my library item for my ceiling. And you can see that over here I've got the U value of 0.045 and I've got a CLTD of 31. So in my head right now I'm going to say 0.045, 31, 0.045, 31. I come back to wall, I go into wall 3 type, and I'm going to go into custom values. 0.045, 0.045 for heating and cooling season, and I'm going to add 31 to my CLTD group. Now in configuration, I'm going to make this a knee wall. Then this is just for clarity on the reports, but I'm going to go ahead and put in that it's an R25 in here with a 0. I'm going to name this thing pitch roof. Okay, so then I'm able to go through this, and I've now built my pitch roof with an extra 540 square feet, which is the ceiling. It is the exact same component as the ceiling, and now it's going to end up in my walls, but it's okay, it'll even out. So now what I want to do is go ahead and add this thing, that wall type, to all 3 of my zones. I've already added it to the attic master, so I'm just going to add this to the upper floor attic top, which is here, in attic game. Again, custom values, call it something, do the values from the ceiling. 31, and knee wall, very important as a configuration. Okay. And by the way, the color of that roof doesn't matter because it's built into that CLTD group. Okay, so now I'm going to go ahead and add the surface area of the walls to the attic. Let's just go back. Before we leave this attic master, we're not done quite yet, and here's why. You can see that in the wall area, I have wall 1, which is 827.7 square feet of total wall area, and that's not correct anymore because it's thinking that my whole room is a cube that's 8.9 feet tall. So really, when I go in here, and again, just to clarify, south is down on this, right? So front door faces south. I don't have any south-facing wall. All of it is facing into the house. That's all what's called adiabatic, or it's there's no temperature difference, no delta T. On my north wall, I have 364.6. I'm going to call that 367 to the north. So I've got 431.7. So 367 minus 431.7 means I need to take out 64.7. And now I've got 367 in my total gross area. I'm going to do the same thing on east and west. There is no wall there. So I'm going to subtract the full 198 and full 198. Now I've got a lot less exterior wall area. I only have 367 instead of 800s. And I've transferred some of that to my roof. In this example, some of you who have been keeping up with me perfectly, by the way, don't forget, comment below if you have questions and stuff like that, but stay to the end and all this will become clearer. Will have noticed that my wall R value is R21 spray foam. My roof R value is R25 spray foam. What's the difference between, like, honestly, if I had walls and roof that were the same, is it kind of a wash? Yeah, it is, but we're going to get to that later because we insulate roofs generally much more than walls, and part of the reason is outer space. Okay, So now we've done attic master. I'm going to go ahead and be quiet for a moment and just do attic game and attic top so that you can watch me do this one more time, but I'm not going to talk through it. 4127 square feet minus 2700 is a difference of 1427. By the way, it doesn't matter which direction that roof faces unless it has a window in it, which we're going to get to. So stick with me. First thing you need to do, remember, is set the volume so that we can set the actual room height. And this is it's important that you do this first because it'll reset your wall heights later if you don't do this right. So 37201. All right, so now I've subtracted out all of the exterior walls, the walls that do not belong in this. I've added in the extra roof that does belong in it. Top attic. 42,829 cubic feet of air. That attic, that one attic out of the three is as big as my entire house. 11.2 foot height. It thinks we have 3,760 square feet of roof. We need 1,733 more. And now we subtract out the walls as well. Now we have fully fleshed out all of these attics. Let's take a look at what our load is. We have a heating load of 104, pretty close to where the encapsulated attic was at 105. And we have a total over here of not 31,000, but 38,000. Now, before we move on, the set point is half tons. Remember, 12,000 BTUs. So 30,000 was 2.5, 36,000 is 3 tons. We would have installed a 3-ton, I'm making quotes in the air. For a 38,000 load, we're not probably installing a 3-ton, although we obviously want to do everything that we talk about in Manual S. There's a whole bunch of deep dives with my HVAC trainer who taught me how to do this trick. By the way, Alex Meany, and he can be found at meanhvac.com. But if you haven't seen those videos, know that there's a whole bunch of other stuff that needs to happen in here. But what we have just found is that just doing what I just did, and there's more, is meaning that we're going to select different equipment just right off the bat. Okay? So I just wanted to make sure that that was clear. Now, the next thing that we really want to look at is the blower door test. Because one of the main problems that they are trying to fix right now as ACCA rewrites Manual J is the fact that the way that blower door testing works in real life, and I know because I'm a blower door guy, I've owned TEC, which is Minneapolis blower door equipment, Retrotech blower door equipment. I've trained people on both of those. I have an ongoing blower door and duct tightness certification program. And when I teach somebody to do a blower door, and when anybody teaches anybody to do a blower door in a house with an encapsulated attic where there's foam in the roof, the right way to do the blower door test is to open the attic hatches. We are testing the entirety of the interior volume that is defined by the enclosure. So a real blower door tester is going to be coming along and doing a blower door test that is going to give you one ACH 50 that is 3288 CFM. That is our target. It could be less than that, that's fine. We know that we've got enough firepower built in here for this. Our volume, as you can see here, is 197,298 cubic feet of air with all of the stuff that we just added. That blower door test at 1 ACH 50 is 3288 CFM. Now let's go back. I'm going to save this. We're going to go back here and look at what the encapsulated is doing. So, same page, 1 ACH 50, 1851. And that is because we are using the ACH 50 metric here inside of Wrightsoft, which is how I would normally do it. It thinks with an encapsulated attic that the volume, and I'm making so many quotes here because this is a semantic problem between HVAC designers and blower door testers. The blower door guy who shows up, or woman, is not going to think this house is 111,000 cubic feet. They're going to say, this is a 200,000 cubic foot house. And they would be absolutely correct. The volume of this house is wrong, the way that Manual J is reporting it, period. By the way, as a side note, if this house had a basement, the writers of Manual J think that volume that's below grade doesn't count. Absolutely not true again, and in that case I need to uncheck this airflow from ACH, and I would need to actually put in the real number, which again is 3488 was the number that we had from our conditioned volume that was correct based on the 3D model in the other model. So now we're not at 1 ACH. For this volume that this thing thinks we have 1.88 ACH, almost twice as much airflow. And that has taken now our heating load up by 10,000 and boosted our cooling load a little bit in this model. So now I'm going to save this, and I just want to make sure that that was clear, because if somebody said, what's your blower to target? And they're like 1 ACH 50, and then the HVAC designer's like, okay, 1, I'm going to put that in here. And what the builder meant was based on the real volume, and what the HVAC designer meant was based on the other, that we could be off by a factor of 2. That's majorly problematic. So just know that that is something that we need to be talking about. They're trying to fix it again, but I don't, can anybody fix everything in the world? Probably not. Next thing that we need to talk about is windows inside of an attic. Is this a thing? Yes, it is a thing. If you have never seen a house with windows that are designed under the attic, then maybe you've never seen an architect-designed home. But they do this all the time. If I have an encapsulated attic that I'm not building in here, remember my floor 2 looks like this. I don't have attic spaces modeled into this thing. I have no way of modeling the windows into the attic. And they might contribute a significant amount of cooling to that. So let's go back over to the conditioned envelope and see what that adds. Right now, by the way, we're at 115,000 heating and 34,500 cooling, so shy of 3 tons. By the way, just to be clear, in the breakdown, you can see that windows are yellow. There is no yellow in here. We're not worried about windows or people or internal loads or anything in these 2 models that I'm comparing. I'm trying to keep this as simple as possible. So the amount of change that we've got between the 2 ways of doing it, this encapsulated attic space that I don't think about, or a conditioned attic that I'm actually going to care about and deliver CFM to, the 2 ways of designing, I'm not worried about what proportional difference there is between the 2. Like, oh, this is going to be 20% bigger, because we haven't added the windows, we haven't added the people, we haven't added the kitchen load, we haven't added a bunch of stuff. Don't worry about it. What we're just trying to do is kind of compare the actual BTUs in this difference. Okay, so back over here on the conditioned attic. Yes, we're going to save. We are going to add a couple windows. I'm going to put 1 window in each attic, and we'll make it a 4x4 window just for the sake of argument. Just 1. We're up to over 38,000, 38,500 BTUs in summertime, and 105-ish thousand heating. And by the way, notice that I'm giving 350 CFM now to this attic game room, 119 to this attic master. These are big room flows. I mean, they're big rooms, let's be honest. Okay, so now we've added the windows. That's just a big question mark. If you're seeing those kinds of plans coming from architects and you're not designing it this way, then you don't really know what it's going to do to it. By the way, these windows, I've modeled them as what the actual client had, which is a U value of 0.28, an SHGC value of 0.22. If those were really crappy windows, then it would do more than it's doing right now. Next thing is ducts. So in my conditioned envelope, I have ducts in conditioned space because I am not guessing what temperature it's going to be in this attic over the game room or in this attic over the master or in the top. I'm making it be the temperature that I want it to be, which is, in this case, 70 degrees in the wintertime, 75 degrees in the summertime. And these are all changeable, for those of you who like it to be 72 degrees all year round or whatever, or I like it to be 68 in the wintertime or 68 in the summertime, which is a crazy idea. Please don't do that. But those are important numbers to put in here, and that is what it's going to lock in on these attics. So in this case, I can see that I'm, let's select all three of these. So I've got my top attic, my attic in the game room, and my attic over the master. The next thing that we're going to look at here is duct heat loss factor. You can see that I have 0 heat loss through my ducts. Here, you can see bright red is ducts. Nowhere in these pie charts am I seeing bright red. And that's correct, and that's good. I like that because now I know for a fact that they're not going to be bleeding my heat out into the attic that I'm not sure what temperature it's going to be up there. Remember when we set those, we'll do that again with the temperature differential between the house and the attic space, but like it's a guess all the time. Okay, so here I'm going to go ahead and say that where I had it set to was most duct systems that I'm inspecting and working on designing for are going to be extremely tight because ductwork is plumbing for air and you don't want it bleeding out all over the place because you want it to get to the fixture that you're delivering it to. That's why we're doing all this, right? So let's say, though, for the sake of argument here, that we think of the attic as encapsulated, therefore code steps in and says, oh, your ducts are inside the enclosure. Whether we model this as an encapsulated attic or as a conditioned attic, in neither case is code going to require that you test those ducts for leakage because they are inside the enclosure, again with the quotes. But if we mess that up and they don't get sealed, you won't find out in an encapsulated attic. In a conditioned attic, if we go completely unsealed with these, we could see that we've changed nothing. I have no extra load that gets added as a result of that. So I'm still locked in at 105,000 heating and at 38,500 cooling. Now flipping back over to the encapsulated attic. If we select both of these and I come back into the same exact place, first of all, you can see we do already have a duct heat loss factor, and that is with extreme tightness with, I'm being nice, an R8 insulation, which is the best insulation. The other one had an R6 on it because you frankly don't need to worry about anything aside from condensation if the attic is actually at the right temperature. So I'm going to get back out of here. I want to show you that in the breakdown here, you can see that we have a duct bleed built into this software in wintertime and in summertime. That's these two pie charts. The bright red is the duct leakage. You can see that in this case, it's coming up at 17% of our total load is from duct bleed. And again, that's where these little blobs of fat that are being inserted, where, like, I don't know, wherever this is, that's why we're still kind of close, because they're saying, okay, well, if you're encapsulating the attic, we'll imagine this a couple degrees more, and then we'll make the ducts bleed some, and that's how we get back some of that stuff that we lose with the surface area not being accurate. Okay, so now let's go in here and change that to unsealed. So we're going to go from a total, we're starting with a total of about 34,500 cooling, 115,000 heating, and the ducts being 7% and 17% of our total load, respectively, per season. If we now unseal these things, because, oops, the guy didn't come that day, and no one's ever going to find out about this because we're not going to test it because it's not required by code. Now, the duct leakage in the summertime is almost 50%, and in the wintertime, it's gone up to 25%. And our total load, by the way, has now gone to 142,000 heat, and that has a lot to do with the fact that the home is a system and that the details matter, right? But for me, sitting here and doing this and trying to decide what equipment is going to go into this house, if I don't say these ducts are going to be sealed tight, right, to my colleague who's like, oh, well, I thought it was an encapsulated attic, we don't have to worry about it. This is the conversation that you need to have, just more conversations, more conversations. Okay, last thing that we need to talk about here is value engineering, because one of the purposes of this software is to help people decide how to construct the house. Like right now, this builder has the R value in the roof because he was trying to be affordable and save some money. R25 in the roof. This is not enough. Like, we should really be building better. I don't know how you pass code. Oh, I do know how. The spray foam guys go in and lobby for code to include a clause that says, oh, R38 is required by code, but if you do spray foam, you could do R30 or R25 or whatever. It's probably fine. That's totally not true, by the way. What they're comparing themselves with is a really crappy bat insulation job. They don't like the fiberglass bats because they get installed badly. But if you're doing a really crappy spray foam job, then it's apples to apples. And in fact, if you're doing a really good job with bats and with air tightness layers, you're doing better, in my experience, than spray foam guys do. So it's not, don't listen to that whole conversation. That's there's too many variables. Okay, so value engineering wise, if we were to take this, we'll start here in the encapsulated attic, and I'm going to, all things being equal, we're going to keep all of the differences that we've built in so far. I'm going to increase my R value of the roof to an R38. And in fact, it's probably R49 is what's code up here. So let's do that, okay? We're going to take our R value to R49 for the ceilings here. And in fact, in this encapsulated attic, I do not have the ability to move the roof insulation past R35. So I'm going to pick R35, and then I'm going to have to go into custom layers, and I'm going to have to make this now R49. Boom. So that's code minimum. We have just tested this out. And by the way, I want to change it up here in the lingo so that it prints out on the report correctly. And now I can see I saved about 10 on heating, and I saved, like a significant amount, probably 12, 15% on cooling. Now let's go back over into the conditioned attic. I'm going to save this. So all three of my attic spaces, there's no other ceiling area aside from this. I have to do two things. I have to first come in here and change my R value in the roof to an R49, R50. And I'm gonna go ahead and play it exactly correctly and change it from an R50 to an R49. I'm going to memorize this 0.03, 40. And now that I've changed that, I can come over to my walls and change this one. 0.03, 40. With a knee wall. With now, instead of R25, we're going to R49. Okay, now we can see that here we've popped underneath 100,000 BTUs of heating, and we've gotten down to, it's about 3 tons still on the total cooling needed for this, this home. So you can see from the variability of all of these numbers that we put in here, with the air tightness layers, with the surface areas, with the windows being built into encapsulated attics, the duct leakage being modeled in and being accurate, it really all adds up. And that's where these low blobs of fat just become super dangerous. I will say as a last note here, this discrepancy between 96,000 heat required for this house and 36,000 required for cooling, this number is wildly wrong. The red number in wintertime is overestimated for high performance homes that are going to be of this air tightness by somewhere between 50% and 120% too big. And this is not just me, this is other people, and you can ask around other HVAC high performance people who are working in this space. That means that we're just going to go ahead and automatically divide this in half. And we get to the point where we could install a 3.5 ton heat pump and likely have it work for this entire house. That being said, if you get somebody who just believes in math alone in America today, that's an achievement. So go with that, knowing that it's not just a math and a science, but it's also an art, because the assumptions built into that red number up there are wrong themselves. You're not going to find that anywhere in the reports. That's another thing that they're trying to solve in this rewrite of Manual J right now. You're allowed to oversize heat pumps by up to 15,000 BTUs per hour capacity to try and hit that heating, but obviously we can't do that here. You're going to be installing, you're going to think that you need to install a furnace AC combo, which is totally not true. Okay, I hope that this has been interesting. I don't know if anybody's still watching at this point, but I think that this is super fun, and if you decide to go ahead and start doing it my way, I applaud you. If you decide to know what difference it makes and go ahead and just keep doing it the old way, that is also fine. Because remember that we're trying to just get 80% of everything right. That'll do most of the job. So if you are attending to the details and making everything pretty good and you end up with a pretty good house, that is fantastic. Good job. If you want to be super anal about it, this is how you do it. So comment below if you have tried this or if you have other things to add about other softwares and how exactly those might work. Like and subscribe. Tune in next time.